All right, so today we are diving deep into some seriously fascinating science. We're going to look at one of the biggest stories in mental health right now, how compounds like psilocybin and LSD can actually physically rewire our brains. Let's get into it. You know, we've all heard the stories about these profound mind-altering journeys, but for scientists, the real head-scratcher isn't just the experience itself, it's what happens after. How can a chemical journey lead to the brain literally rebuilding itself? How does the mind end up reshaping its own matter? To even begin to understand that, we first have to talk about why this question is so incredibly important right now. And it all starts with this idea of a brain reset. We are right in the middle of what people are calling a psychedelic renaissance, and here's why. The research is showing that these compounds can have therapeutic effects that are, and I'm pulling this from a recent study, rapid, robust, and can be long-lasting, sometimes even after a single dose. This is so promising that the FDA has actually granted psilocybin breakthrough therapy status for depression. It's a completely different way of thinking about treatment compared to traditional daily medications. So all of this incredible promise left scientists with one huge, fundamental question. I mean, it's one thing to see these amazing results, but it is a whole other thing to understand precisely how it's all happening. What is the actual biological mechanism at play here? To answer that, we have to zoom in. I mean, way in. All the way down to the very first moment a single psychedelic molecule meets a single brain cell. This is the story of that first molecular contact. Okay, so let's meet the main character in this whole drama, the 5-HT2A serotonin receptor. Just think of it as a master switch on the surface of your neurons. When a psychedelic molecule latches onto this specific receptor, that's it. That is the key event that kicks off the entire cascade of effects. It is literally the first domino to fall. But here's the thing. Scientists have known this switch was being flipped for decades. They knew the interaction was happening, but they could never, ever see it. And without being able to get a clear picture of that first moment of contact, figuring out the exact mechanics was pretty much impossible. Until now, using some absolutely cutting-edge imaging, researchers had a massive breakthrough. The Psychedelic Science Review put it perfectly. They solved the long-awaited crystal structure of LSD bound to the activated 5-HT2A serotonin receptor. This was a total game-changer. You know, what this breakthrough really means? It's like seeing a key fit perfectly into a lock for the very first time. For years, we knew the door was opening, right? But now, finally, we can actually see the key slide in, we can see it turn the tumblers. It's a whole new level of understanding. Okay, but seeing the key turn the lock is really just the beginning of the story. The real question is, what happens after that door is unlocked? How do our neurons actually start to rewire themselves? And this brings us to this absolutely crucial concept, neuroplasticity. It sounds complicated, but it's really just the brain's natural ability to remodel itself, to change its connections and behavior. It's the physical basis of how we learn, how we adapt, and how we heal. So this led researchers to the next obvious question. If flipping that 5-HT2A switch is what opens the door, does that action directly trigger the brain's whole remodeling process? A landmark study using human brain cells gave us the answer. And honestly, it's a visual one. Just look at this. On the left, you see normal neurons, just kind of doing their thing in a petri dish. Now look at the right. Those are the same kind of neurons after being exposed to psilocybin. That's the active form of psilocybin. The difference is just staggering. It's an absolute explosion of new connections, a huge increase in complexity. So how in the world does this happen? Well, the study mapped it all out. You can basically think of it as a miracle-grow effect for your brain cells. First, the psilocin hits that 5-HT2A receptor. That simple action triggers the release of this really important protein called BDNF. And BDNF acts like a potent fertilizer, causing the neurons to physically sprout new branches and grow. And all that new growth leads directly to more and stronger connections between them. And what's just so remarkable is that scientists have now mapped this whole molecular chain reaction that causes this growth. This is the detailed blueprint. Now, you don't need to memorize this diagram or anything. The whole point is to just show that we now have the biological schematics for how a single molecular event, that key turning in the lock, can set off these huge structural changes in the brain. Okay, so we've gone from the big picture all the way down to the molecule and back up to the cell. So now let's zoom out again and ask the big question. What does all this mean for the future of medicine? It means we could be looking at an entirely new class of medicine. The researchers who figured this stuff out even coined a new term for them, psychoplastogens. It literally means mind-molding producers, which is just a perfect name to describe their ability to promote all this neuroplasticity. And this really does represent a true paradigm shift. Think about it. Traditional antidepressants often work by managing symptoms, and you usually have to take them every single day, sometimes forever. Psychoplastogens are totally different. The idea here isn't to just manage symptoms day to day, but to actually promote structural changes in the brain that could lead to rapid and sustained healing, maybe after just one or a few doses. So the crucial takeaway is this. We might be moving from a model of just masking symptoms to a model of prompting the brain's own amazing ability to heal. You can think of conditions like depression or anxiety as these deeply worn grooves in the brain, these rigid, stuck pathways of thinking and feeling. Well, this research suggests that psychoplastogens don't just smooth over those grooves. No, they might actually provide the raw biological material for the brain to carve entirely new paths, creating a more flexible, a more resilient mind. And that leaves us with a pretty profound final thought. For the very first time, we have visual, we have molecular, and we have cellular evidence that we can actually prompt the brain to physically heal itself. So the question really isn't if it's possible anymore, it's what does this mean for the future of mental health now that we know we can?